Okay, we're going to look at this inverse function question. And here we go. The function f of x is equal to 3 to the minus x. Okay, you're given that function. And the first thing you're supposed to determine is f to the minus 1. That means the inverse function of f of x. Well, this 3 to the minus x, it's really 3 to the minus 1. It's easier for me if I think about this 3 to the minus 1. If you know what that is, that's 1 over 3. So the function is really y equals 1 over 3 to the positive x power. So 3 to the minus 1 is 1 over 3. There's your function. Now if we're going to find the inverse, what we have to do is switch x and y. Well, there's the first step. So x equals 1/3 to the y power. Well, that's just exactly what the inverse is, but it's supposed to be in the form of y equals, and we can't do that unless we use logs. Now, exponents really are logs, so that y is the log to base 3 of x. And if you know that, you can go y equals the log to base 1/3, I should say, not base 3. There's the base 1/3. The log to base 1/3 of x. Now, there it is in the form of y equals. So f to the minus 1 of x is equal to the log to base 1/3 of x. Now, the next question they ask there is to sketch the function. Well, just find the y-intercept. We're going to sketch a function. You put in 0. 1/3 to the 0 power is 1. Okay, now I think minus 1's a nice number to put in there. Minus 1. 1 over 3 to the minus 1. Put it in your calculator. You'll see that it turns this upside down. It becomes 3. Minus 1 and 3. Now if you put in 1, you get, if you put in 1, you get 1/3. You don't have to graph that, because the basic shape, you know what comes through, goes to 1 and gets closer and closer but doesn't touch the x-axis. So there's the sketch of 1/3 x. Now how do you sketch the inverse? Well, it's pretty easy, because all you do, you switched x and y here to get the inverse. All you do is switch x and y here. And so instead of minus 1 and 3, go to 3 and minus 1. Instead of 0 and 1, go to 1 and 0. And instead of it getting closer and closer to the x-axis, make it get closer and closer to the y-axis. Now, this is a computer did this. It makes it perfect. You just need that basic thing there, that it's bending out this way. Now, all inverse functions have a mirror, kind of an axis of symmetry here that they get reflected about. The line y equals x, 1 and 1, 2 and 2, 3 and 3, all the way where y is always equal to x. And it should be like a mirror. If you're over here, you see yourself in the mirror over there. If you're here, there's your reflection over there. That's reflection of the line y equals x. That's an inverse function. The next question says, determine the reflection of f, it's h, a reflection in the y-axis. Well, you have to know, there's your f. To reflect in the y-axis as a mirror, there's a rule. Whatever x is, you change the sign. So instead of minus 1 and 3, you make it 1 and 3. Instead of 0 and 1, well, the minus of 0, it just stays the same there. But if it gets reflected around this line, it'll look like this. There's the reflection. There's the function. And there's the reflection. And the y-axis is the mirror. If you had minus 1 and 1/3, the reflection would be over 1 and 1/3. The reflection would be minus 1 and 1/3. That's the function h. We just showed that reflection. Now the last question says, for which values of x will the inverse function become negative? Well, first we take a look. What's the inverse function? Oh, it's this one that was the inverse function. When does it drop below 0? When is it less than 0? Well, there it's greater than 0, 3 and 2 and 1. There it's equal to 0 at 1. Down here, right down here, that's when it goes negative. So it's when x is greater than 1. You see this red line here? That's the place where the inverse function gets less than 0. Well, I hope that explains all the questions.